All right, let's dive into a really high-stakes logic puzzle today. I'm talking about a puzzle where, your life is literally on the line if you don't get the right answer.
So how do you solve a giant problem? And I mean a really giant problem. This isn't just some fun little brain teaser. This is all about survival.
Okay, so picture this. You work for a family of giants. Yeah, actual giants. They're getting ready for this big, fancy dinner party, and they all want to look sharp. But, oh no, there's a huge problem. A disaster! The head giant's favorite shirt, it's a total mess of wrinkles. We're talking a giant-sized mess here.
And to fix this, you need the giant iron. Sounds simple enough, right? Well, this is where our real trouble kicks in.
So here's the puzzle you're actually facing. And just to be clear, this isn't really about ironing a shirt. It's about making sure you don't end up on the dinner menu. Okay, so the iron needs 2 working batteries to power up. You've got a pile of 8 batteries right in front of you. The problem is, the baby giant got a hold of them and mixed them all up. So somewhere in that pile, you have 4 that work and 4 that are totally dead. Your job? Find a working pair.
And here's the catch, the really crucial part. You have to find that working pair in 7 tries or less. The clock is absolutely ticking.
Because let's be real, if you can't get that iron working in time to get those wrinkles out, well, the giants are going to find another use for you. And trust me, you don't want that. The stakes could not be higher.
So what's your first move? What's your gut instinct here? How would you start testing those batteries? Go on, think about it for a sec, because the most obvious answer is actually a trap.
Yeah, that obvious approach? It has a name. It's called the brute force method. And in a situation like this, it's a complete recipe for disaster.
You could just, grab any 2 batteries, pop them in, and see what happens. Hope you get lucky. And hey, you might find a working pair on your very first try. But you can't bank on luck, not with your life on the line. You need a strategy that's guaranteed to work.
And here's the math behind why that's such a bad idea. With 8 batteries, there are 28 possible pairs you can make. You only get 7 tries. You just don't have time to guess.
So the key here is to think like a strategist. You have to assume the absolute worst-case scenario. You have to plan for getting unlucky again and again and again. A random approach, it just isn't going to cut it.
Okay, so if just guessing, brute force, is out, what's the answer? Well, it turns out there's a powerful clue hidden in the math of the problem. A clue that changes everything.
Here it is. This is the key. Since there are 4 good and 4 dead batteries, think about this. Any pile of 6 batteries you choose has to have at least 2 good ones in it. It's a mathematical certainty. That is the insight we're going to build our entire strategy on.
So what does that clue tell us? It tells us the solution is all about dividing the problem into smaller parts. Don't look at it as one big pile of 8. Break it down into smaller, manageable groups. That's how we're going to narrow down the possibilities and find our answer.
And this line of thinking leads us to a really elegant and, more importantly, a guaranteed solution. We're going to call it the 3-3-2 strategy.
Okay, here's how it works. First step, split those 8 batteries into 3 groups. You'll have a group A with 3, a group B with 3, and a group C with just 2. Now, you start with group A. You test all 3 possible pairs you can make from those 3 batteries. Let's imagine the worst-case scenario. None of them work. Okay, that's 3 of your 7 tries gone. Then you move on to group B. You do the exact same thing. And again, let's stick with the worst case. All 3 pairs in that group fail too. That's another 3 tries, so we're up to 6.
Now this is so important. What does all that failure actually tell us? Well, if you test all 3 pairs in a group of 3 and none of them work, you know something for an absolute fact. That group cannot have 2 or 3 good batteries. It has to have either one good one or none at all. See? Even failure gives us really valuable information.
Okay, let's recap our worst-case scenario. We've used up 6 tries. Group A failed, Group B failed. What that tells us is that across those first 6 batteries, there's a maximum of 2 good ones. Maybe 1 in Group A and 1 in Group B. But hang on, how many good batteries did we start with? 4, right?
And right there, that leads to this amazing aha moment. If there are at most 2 good batteries in the first 6, and we know there are 4 good batteries in total, then the 2 batteries left over in Group C, they have to be the working pair. You found them. You don't even need that 7th try to test them. Logic tells you they're the ones. And boom, just like that, you've cracked it.
You either found a working pair in the first 6 tries, or, in the absolute worst case, you are guaranteed to know which pair works by your 7th move. The shirt gets ironed, the giant is happy, and you get to live another day.
So there you have it. By breaking the problem down into smaller pieces and using pure logic instead of just hoping for luck, we found a guaranteed solution. And, we saved ourselves from a pretty gruesome fate.
But this riddle, it's really more than just a fun little puzzle, isn't it? This whole strategy, taking a huge, complicated problem and breaking it down into smaller, manageable parts, that's an incredibly powerful tool for solving all kinds of challenges. So the question I want to leave you with is this. What giant problems in your own life could you solve not by trying to tackle them all at once, but by breaking them down, piece by logical piece? Something to think about. Thanks for joining me.